Good morning, everybody. This is Steve Spear. I'm here with my colleague, Matt Waters. For sure, it's true for the Navy of the United States, and it's likely true for her many allies as well, that there's pressure to have more ships and more planes present where they can be of use. One alternative towards achieving that goal of more ships and more planes is adding to the numbers that are already commissioned. The obvious problem with that is the cost and time involved. The alternative to just spending and buying more, and one that has tremendous appeal to the operational nerds and fiscal tightwads amongst us, is getting more and better use out of the assets that we already own. And when one considers the amount of time that capital equipment spends being repaired and maintained versus the amount of time the same equipment actually spends deployed on patrols and missions, the appeal of doing more with what we already have is obvious. Now here's the problem. These assets have schedules constructed well in advance as to where, when, and how they will be used, and where, when, and how they will receive maintenance and repair. And just as the schedule of deployment is at best a guess of what the actual needs will be, so too the prescribed schedules for maintenance and repair are at best guesses for what these expensive and complicated assets will actually need. Consequently, when this equipment arrives at an airfield or a shipyard, what's actually required differs from what's expected, and how that work should actually be done differs considerably and in remarkable ways from what's been prescribed and written in advance. Despite that, when people go to do their actual work and find that there are gaps between what's been predicted and what's actually required and necessary, they have trouble drawing attention to those discrepancies. So they have trouble getting help. This is precisely where this maintenance knowledge framework comes in, to close the gap between what's predicted and what's actually required, so there's higher levels of performance and much less variance and variability and unpredictability in the experience. First, the Navy has enormous amounts of data from past evolutions about what work was actually needed on different ships and different planes in response to what use a ship or a plane actually experienced. The challenge is collecting, collating, and finding structure in that data to make better predictions about what work actually has to be done. The problem is that the richness in that data is presently not well tapped. Second, Navy personnel, particularly salty old chiefs and their shipyard and airfield counterparts, have tremendous experiential data and implicit knowledge about how to perform work tasks in an effective and in an efficient way. Less experienced sailors, technicians, and mechanics do their work without having that wise old chief whispering advice and giving direction into their ears. Third, when uniformed and civilian workforces find something amiss, they're disconnected from the larger system in which data is collected and processed in order to inform decisions. The workforce is left to cope, firefight, work around, and otherwise make do with the situational vagaries that they encounter, while those planning what work has to get done and how to do that work are left unaware of what adjustments they should make in their planning, informed by the reality of recent experience. It's in response to these three conditions that we've conceived of this maintenance knowledge framework. First, our colleagues at Amazon Web Services have extraordinary experience taking data recorded in legacy ways and converting that into modern digital formats that can be explored, investigated, and otherwise worked with to gain a much richer understanding. Second, we have tremendous capability with Matt's Ava Studios, which has raised to an art and even a science how to take complex, rigorous, and demanding technical instructions and convert them into multimedia coaching tools that both harness the best collective understanding how to do something and also put that understanding into the mind and into the hands of those at the point of directly doing the enterprise's work. It's almost as if people have, if not the real wise old chief, a virtual wise old chief looking over their shoulder and whispering into their ears. Third, we work from the premise that no matter how well informed something is, be it a comprehensive workflow or a detailed work instruction, that there will be idiosyncrasies that couldn't be known or weren't considered in advance. Therefore, we build into this whole undertaking a means of generating, recording, digesting, and responding to quick and easy feedback that what has been anticipated is not exactly what is being experienced. Those doing work can get help assistance real time to close those gaps and contain those discrepancies. And those doing the planning can adjust the algorithms that they have mined from the data and the guidance that has been constructed from collective wisdom. They can continuously update and refine that. Net, the proposition is that an organization taking advantage of these three elements in the maintenance knowledge framework will be better able to go through its own maintenance and repair evolutions, and better, faster, and easier. Actually, much better, much faster, and much easier than it would have otherwise, thereby giving it the ability to deliver far more capability to the forces it supports than it would have otherwise.
Hi there, folks. This is Matt Waters with Ava Studios. First, thank you, Steve, for providing us with that organizational view of where we are and where we want to go with MKF. As Steve mentioned, MKF will be a collaborative approach to improve the speed, accuracy, cost, and safety of equipment repair and maintenance here in the U.S. It will consist of three main elements, and these include what to do, how to do it, and then constantly asking ourselves the question, should we keep doing it this way? Since the how-to portion of this lends itself to being demonstrated, that's exactly what I'm going to do. I'm going to show you what this will look like in MKF. As you all know, performing repairs, maintenance, or equipment updates is complex stuff. If it's not done right, the consequences can be significant in respect to cost and readiness, and this is especially true with aircraft. One pretty big challenge is the ability for most people to correctly interpret text-based instructions. Everyone naturally visualizes what they read, and no two people are going to interpret things exactly the same way. The U.S. Navy developed the specs and standards for a solution back in 2004, a full year before YouTube, and it was in the form of job aids. Since then, all branches of the U.S. military have developed job aids for some of their more troublesome maintenance issues, most of these with maintenance steps, quite frankly, that needed to be seen to be understood. What we refer to as visual microlearning will be integrated into the maintenance knowledge framework, and it's intended to remove any doubt about how a task should be performed. To help illustrate what this will look like, let me share a commercial example that was produced for Toyota. A quick backstory to this project. Toyota was looking for a solution to a quality problem they were having on their new Highlander vehicles. At each of the three locations where they were applying paint protective film to the front of the vehicles, there was only one technician who could do it correctly. So they needed a way to illustrate to other technicians how this film should be applied. The first thing you'll notice is simple navigation. Text is to the left and media to the right. Navigation buttons are at the bottom, and the ones you use most are the next or back buttons if you happen to be moving step by step through the process from the beginning, or the contents button if you need to jump to a particular step in the process. The navigation also transitions from a desktop version to a mobile version, which you see here. This is in case a user needs to view the job aid on a small viewing device like a cell phone. The point here is to make it easy for a first-time user to get to work, rather than be confused about how to use the interface. We don't have time to go from end to end with this example, but let's play the introduction to get an idea of what's covered in this job aid for Toyota.
Welcome to the Front Bumper Clear Paint Protection Job Performance Aid, JPA. This JPA will help you understand how to apply a clear protective film to the front bumper of a Highlander vehicle, which will include properly sealing edges, special application techniques, and specific tools needed to do the job. To begin, select the Next button. If you would like more information about navigation, select Contents and then User Guide.
The introduction gave us an idea of the overall scope of the work. Next, we get a look at the tools and materials needed to begin the work. If I go to Contents, you can see there are a number of steps to the process. I'll play a couple of these so you can get an appreciation for the work that needed to be performed.
Caution. As the film is first applied to the bumper, be careful to take your time around the fog light, since it is easy to tear the film in this spot. Loosely place the film onto the bumper.
Now, as you watch her, keep in mind this is the one person at her facility who knows how to properly apply the film. So in the future, other technicians at all three facilities can observe what she does as many times as they want to learn such things as how she holds the film or the pace at which she works. One of the things you'll notice in the sample screens is how rich the process is in technique. Let's face it, written instructions will never communicate those things that have to be seen to be understood. Here's another example.
Slightly pull the film to the corner of the bumper where the headlight meets the fender. While keeping your edges within tolerance, lock this corner into place. Alcohol solution can be used anytime you are stretching the film, to prevent the film from pulling back. Remember to keep a gap between steps 3 and 4 for now. This will be used as an exit for fluid in step 7.
I'd like you to notice one more thing about the video clips you've seen. Notice how brief they are. Most will have a running time of between 30 and 40 seconds on average. There's a reason for this. Long-running videos are difficult to use on the job because they require constant stopping and rewinding to move at the unique pace of each user. The information has to be broken into smaller micro-learning segments that allow a user to watch and then perform the steps. This also helps users better remember what they've seen. I'm pretty sure you can appreciate why this sort of visual approach was valuable to Toyota, and why it can prove just as valuable to equipment readiness in the military, where the processes are a lot more complex than applying plastic with soapy water. It's the reason why visual microlearning is an integral part of MKF. In closing, I think it's helpful to consider those areas that will benefit most from MKF, which include a systemized approach to leverage historical maintenance data to predict repairs well in advance of when you'll need them, modernization of outdated text-based maintenance manuals, an approach to integrated training at the toolbox level where technicians can benefit from it most, a way to capture that important experiential know-how of your most seasoned technicians, and even a way to change the paradigm of how expert tech rep support is provided in the future.